Hi everyone. Let's go through this question. So we have a charged cork ball of mass 1 gram is suspended on a line string in the presence of uniform electric field as shown in this figure. The electric field is given, and it's given by this vector, or we have the x component and y component of the electric field. So we have the x component, so this is Ex, and the y component multiplied by 10 to the power 5 Newton per coulomb. The ball is in equilibrium with theta is given, so we have theta equal to 37 degrees. The question asks find A, the charge on the ball, and B, the tension in the string. Okay, so let's go through this. So first thing we need to think about the problem. So we have this particle or this ball here. It has a positive charge Q, and it looks like this moves. Of course, it's expected to move with the electric field, and momentarily or it's at suspension, so we know that the sum of the forces affecting on it is equal to 0. So the starting point of this, simply we need free body diagram to draw free body diagram for the Q. So obviously we have three forces affecting on the charge. The first one is mg, gravitational force, and then we have the tension force, and of course we have the x component of the electric force and the y component of the electric force, because we have Ex and Ey multiplied, of course, by 10 to the power 5. So we have Ex and we have Ey, means y component of electric field. And obviously, because of this electric field, electric force will be affected on the charge, given by the following equations. So force is equal to Q multiplied by E. Because electric field has two components, so force will have two components. Okay, one component will be on the x-axis. Let's call it Fx, which simply equals to, according to this equation here, the x component will be equal to Q multiplied by Ex. Okay. And I could put a unit vector I just to make it, formally, because here we have a vector, so it's Ex, and we have the y component. So we have Fy equal to Q Ey. When I put arrow on the Ey, I mean it with the direction. So in this case, the unit vector is J, but I'm not going to involve the unit vectors in the solution. Okay. So now we have three forces, and we have our coordinate X and Y. So it looks like there is one force, which is tension, need to be decomposed into its component, right? So we have this angle theta, means we have this angle theta. Now the tension will have two components, of course. This will be T sine theta, and there will be another component here given by T cosine theta. Okay. So according to the equation, we have the summation or sum of the Fx is equal to 0, because the ball is at the equilibrium, so the sum of the x component is equal to 0, means x component of the force is equal to 0. So this is simply going to give us Qex equal to T sine theta. It's called equation 1. And we have the sum of the y component of the force also equal to 0. So we have two forces upward. It's a Qey plus T cosine theta equal to mg. Before I name this equation 2, let me just rearrange it. So this is equal to Qey. I'm going to move mg to the left side, and I'm going to move T cosine to the right side, cosine theta. Now I'm going to call this one equation 2. Okay, so we have equation 1, we have equation 2. So physics finished here. It's just mathematical steps. It looks like we have two unknowns. So we have T and Q, and we have T and Q. So there are different approach to solve this. The way I'm going to think about it is just simply I'm going to divide equation 1 by equation 2, because I want to get rid of tension first. find Q, and then after I find Q, I'm going to bring it back to substitute the value of Q in equation number 1. So let's just separate this. Okay, now I'm going to say equation 1, so 1 divided by 2. It's going to give me this. And maybe I have no space, so I'm going to write it over here. So t sine theta divided by minus t cosine theta, so I have minus tangent theta equal to QEX divided by the left hand side, which is QEY minus mg. Okay, so I could get the value of Q simply by doing multiplication. So now I have QEX. So tangent theta multiplied by those, and I'm going to move everything to the left side. So it's going to be equal to plus QEY tangent theta, right? Minus time minus positive. I'm going to move it to the left. It's still negative, so it's equal to mg tangent theta equal to 0. Okay. So it looks like I have a Q here and I have a Q here. So I could factorize this, and the final answer for Q will be equal to, I'm going to move this term again to the right side. So this is going to be equal to mg tangent theta. Okay. And if I factorize Q in the first two terms, so here would be EX plus EY tangent theta. Okay. It looks like we have all these parameters, right? So we have, I'm not going to do the final steps. So we have the mass, we have gravitational acceleration, or acceleration due to gravity 9.8, we have theta, we have EX, EY, we have everything here. So Q simply, after you substitute all the numbers, Q simply is going to be equal to numerical value and given in column. It's important to make sure that EX is equal to 3 times to the power 5 and 5 times 10 to the power of 5. Okay. So this is one result. This is part A. To find the tension, we basically simply substitute the value of Q into any of the equation, but the equation first, or the first equation will be E. After you substitute Q in equation 1, you could find, you could get tension, right? Get the value of tension to in Newton. Okay, so this is the solution. I hope it's clear. Thank you for watching.